Hi, we're continuing where we stopped off in the last video. This is question number 14, part B. It deals with the motion mainly of Q. We are told, please keep an eye on the question, yeah? Q accelerates from rest with variable acceleration. Note from rest, so initial velocity is 0, u is 0. The acceleration is given as 1 plus kt. And you're told that first thing, k is a positive constant. And you're told also that q passes p when t is 10. So which means that when t is 10, the displacement of P will be equal to the displacement of Q. Same idea as overtaking. Yeah? Q passes P when T equals to 10. So when T equals to 10, SP, the displacement of P equals to SQ. Also, A, we know is dV dt. And we also know that V is ds dt. So if you want to go from A to V, we have to integrate. Okay? And we want to go from V to S, we have to integrate. Only idea in this part of the problem is this. So let's start with the displacement of P. We know that from the earlier part, SP equals to T squared. And when T equals to 10, okay, when T equals to 10, the displacement of P is 10 squared is 100. Easy. Now what we are going to do is we have to set the displacement of Q. Again, we know that the displacement of P is 100 when T equals to 10. Now, because Q is going to pass P at T equals to 10, we have to set the displacement of Q as equals to the displacement of P. So we have to set SP equals to SQ. That's what you see here. Set SQ equals to 100. A quick summary. When Q passes P, the displacement of P equals to the displacement of Q. Okay? The displacement of P equals the displacement of Q. So, let's come back here. We have A equals to 1 plus kt. So I want to get my velocity function. I integrate. That's easy for you to do. You integrate. Easy for you to do. When you integrate 1 plus kt, you will get t plus k over 2t squared plus c. Note, I'm going to get rid of the c because I know when t equals to 0, v is 0, initial velocity is 0, and I'll get my velocity function, t plus k over 2t squared. I need to integrate this again because I want my s function, my displacement function. When you integrate this again, you will get t squared over 2 plus k over 6t cubed plus c. Again, I want to get rid of my c when t is 0, s is 0. So the displacement of q will be equals to t squared over 2 plus k over 6 t cubed. Now I'm not saying much about the integration because it's very easy to do. Yeah. Now remember SQ is how much? 100. That's what you see here. Okay, when t equals to 10. So you plug in 10 here, you plug in 10 here, and you plug in 100 here. This is what you'll get. Clean up the algebra. Okay, clean up the algebra, and you'll get k equals to, okay, hang on, let me just clean that up a little bit. When you clean up the algebra, that's easy to do, yeah? K over 6 times 1000 equals to 50, and you'll get k equals to 6 over 20, which is 0.3. Let's finish the problem. In part 2, you're asked to show that at the time when P reaches 90 km per hour, Q is traveling at a speed just less than 130 km per hour. This is not difficult except that you have units, just be a bit gentle with it. Okay, from kilometer per hour, you want to change it to meter per second, you have to times 10 over 36. From meter per second, you want to change it to kilometer per hour, you need to multiply by 36 over 10. So P reaches 90 km per hour. We found in the earlier part. Let's look at the solution. P reaches 90 km per hour when time equals to 12.5 seconds. Yeah. Again, in the earlier part we worked out t equals to 12.5. That's when p reaches 90 km per hour. So now we want to find the velocity of q when t equals to 12.5 seconds. So let's use the velocity function from above. Okay, the velocity function from above, that's what you see here. T plus k over 2 t squared. Again, t plus k over 2 t squared, except that now we know the value of k. Okay, we know the value of k is 0.3. So I've written here t is 12.5. You can work out the velocity of q. Plug the numbers into your calculator, you will get 35.9375 meter per second. What do you have to do next? Yes, multiply by 36 over 10 so that you can convert it to kilometer per hour, and you'll get an answer 129.375 kilometer per hour, which is just less than 130 kilometer per hour. And we are done. Please like this video. Please share this video with as many friends as possible. Please follow me on Facebook. Please follow me on YouTube. Thank you very much. This is themathcenter.com.